coffee is placed on a counter and allowed to cool. The temperature T, so this is 81, uppercase T and in degrees Celsius, fine, of the coffee T in minutes, okay, after being placed on the counter is given by, and they are giving us the function. I don't really like T of T, but because we have to be careful, right? So uppercase T is temperature and lowercase t is time, plus 45 e to negative 0.023 t. What was the original temperature of the hot coffee? Part A, original. What does original or initial always represent? Always, initial.
Zero.
Yes, yes, yes. So initial, original, oh, sorry. Initial or original is always time equals 0. Okay, same thing. So all I have to do is plug in 0, but plugging in 0 is not a big deal. This is 0. So how much is e to 0?
1.
Perfect. How much is 1 times 45?
45.
And how much is 45 plus 30?
75.
Good, that's done. Excellent. Part B. Let's see what they want. What is the coffee's temperature after 20 minutes? And the time is in minutes. So what am I going to do now? In part B, time in minutes is given to us. T equals 20 minutes.
You put 20 in as T.
Very good. So we want T of 20. We're going to determine it in a minute. Let's see part C. When will the coffee's temperature be 35? What am I asked this time? When will the temperature be 35? What do I need to do next?
The equation equals 35.
So 35 equals 30 plus 45 times e to negative 0.023 t. Good. So let's plug this. You know how I like it. It's easier for me because sometimes they ask me to plug in several times and I don't really want to plug it in or write the equation several times. So it's easier for me to write it once. So 30 plus 45 e, and I also see it to make sure I don't have an error when I typed it in. 0.23, and that's times t. Good. So this is our function. And yes, you can quickly, just making sure, you can plug in 0 and you get 75. And now we can plug in, they say 20 minutes. And let's see the temperature. It drops to 58.41. 58.41. Do not forget the measurement unit, degrees Celsius. Okay. Now part C is different. What do we do? This is the third.
Part A?
Say it again.
Can I see part A and copy it down?
I just plugged in 0.
Oh, okay. That's what you did.
So,
Okay.
yeah, that's it. Good. So what do we do next? Anyone? Nathan, are you with us? Would you tell us what to do next?
Do you add the 30 and 45?
I cannot. By the order of operations. That's why it's so important. Yes. So yes, we're going to subtract 30. Yes. So we have 4. Very good. Perfect. And next, anyone else? What is the next step? Destiny, can I hear from you?
You want to know what the next step is?
Yes, what do you think?
Do you multiply both?
I cannot. I have to solve for this.
divide.
Excellent. Yes, of course. E to negative 0.023t. And now what do we do next? Let's say, Cameron, I haven't heard from you today. What do we do next?
Do you take the natural log?
Absolutely. Very good. Awesome. We apply natural log to both sides. Awesome. So natural log, thank you very much. I could have simplified, but there is no need. I bring the power in front. And I should write times natural log e. Can anyone tell us what is natural log e?
1.
Thank you very much. So then t, I meant to write colon or comma, whatever. T equals, please, this is compact, one number. Natural log of 5 over 45 divided by negative 0.023. Be very careful how you enter this in the graphing calculator, please. So,
Would you want us to simplify the 5 over 45?
oh no, because we're going to put it all together, but you can as 1 over
Okay,
9.
so we don't have to.
Yeah, no, because we're going to approximate. Very good point, yes.
Okay, perfect. Thank you.
So careful with, thank you, natural log in parentheses 5. If it's easier for you to enter it as 1 over 9, yes, of course, you should do it. Divide, do not forget parentheses. You have to have parentheses around the denominator because it's a negative number, and you have to start with this negative, not with the operational negative, with the symbol negative, not the operational negative. So close and enter, and this is 95.53. So 95.53, what is the measurement unit?
Minute.
Yes. Good. Anything, I think there was something else. I think there was part C or D. Yes. So find the limit. So this is the last part. Part D, find the limit as t approaches infinity from t of t. Okay, perfect. So I'm going to write limit t approaches infinity, and I'm going to write the function, which is 30 plus 45 times e to negative 0.023t. Awesome. So when we find the limit, can anyone refresh our memory? What do we have to do first? We're asked to find the limit of something. What is the very first thing we need to worry about? Always, for any limit, what did we do first? Always. There is always our first priority when we calculate a limit. What do you think? Anyone?
Is it find the domain?
No, something else. We plug it in, right? We don't know what this is. We always have to plug it in. We agree? We remember that?
Agreed.
We always plug it in. So let's plug it in. I'm covering this because I don't want you to get confused. So there is no t here. That's why I'm covering them. So if t approaches infinity, where is this piece going? This piece.
Is it negative?
Negative what?
Negative less than 1?
T approaches infinity.
Go to negative infinity?
Negative infinity. Good. Now we have a number raised to negative infinity. And we know this. E to negative infinity is the same with 1 over e to infinity, correct? Would you agree with that? This is the power rule for the negative exponent, right?
Agreed.
Where is this going?
Positive?
I have $1 and I want to divide it by billions of people. When I get to your door, how much will you get?
0.
0. So this whole thing approaches 0. What about 45 times 0? Everybody, how much is 45 times 0?
0.
Good.
So
How much is 0 plus 30?
30.
What is the limit then?
30.
30. You can say that was a little complicated. Okay. If it was a little complicated, if you say that, then let's go here. That's why I want to, and I like to have the function in there. I'm going to go to second and table. And we are, t approaches infinity. Give me a number. Give me a big number.
500.
500. Good. Give me a bigger number.
1,000.
Very good. A bigger number. We got the point, or we need to go to another bigger number? We got the point. We got the point. The limit is 30. Okay, what does this mean? Well, 30 degrees Celsius, the ambient temperature probably. So as time goes by, as time goes by, the temperature of the cup of what it was, coffee, cannot go below 30, because I'm assuming that's the temperature around the cup. Good. Okay. Any questions on this for me? Any questions? Okay. In that case, I would like us to continue with, finally, some calculus with these functions. So we're going to look at 2.2 and 2.3 together. So of course, this is the derivative of exponentials, and this is the derivative of logs. So derivatives, and which page am I on so I don't mess it up? 4. Derivatives of e to the x and natural log x and some other more complicated exponential and log. Okay, so first of all, I wanted to give you very good news that e to the x prime is itself. And that's very good news. Very simple. Also, when we differentiate natural log, we get 1 over x. Now, finally, before we look at applications here, what if I have a function? Do you remember when we said x to power n prime? Can anyone refresh our memory on this formula? Anyone?
nx n minus 1.
Yes. And do you remember what I said?
Times the original.
The inner function prime. But it was not needed because this was 1. But when we moved on to a function, not plain x, what did we say the formula was for this one? Anyone would like to try? It's the same formula. Nothing else, but just this.
Is it m times f to the power of m minus 1?
Here I didn't have to write it because it was 1, but this is not 1, it's a function.
Times the inner function.
Prime, yes. So this is what we have to apply. For this, when x is not x but a function, and when x is not x but a function. So let's try e to a function now prime. Anyone would like to give it a try? And then natural log of a function prime. It's okay if you're wrong, just give it a try. Anyone?
F times E.
Careful.
F
So we
minus
have to look here. So e to f prime has to be e to f. Here I should have written times x prime, but I didn't because there is no need. It's 1. But here I have to do what? What should I write?
Is it x prime?
Not x. It's not x.
For the X.
Prime.
That's it. Can anyone discover the formula for, this is the pattern. Can anyone discover the formula for natural log of a function prime? Based on what we see here. And yes, I should have said times x prime, but I didn't because there is no need. That is 1.
1 over f times f prime.
That's it. Thank you very much. Who was that?
Oh, Levi.
Levi, thank you. So this is plain x, and we don't need to multiply by x prime because that will be 1. This is plain x. We don't need to multiply by x prime because this is 1. But if this is anything else but x, then we have to multiply by the inner function prime. If this is anything else but plain x, we have to multiply by the inner function prime. That's all I had to say, and now we're going to practice anything we can. Where is my book? So we want to go to page 210. Enter.